The tentpole new feature for SQL Server 2019 is called Big Data Clusters. Big data clusters are not so much of a new capability as they are a melding of many existing features and technologies into a single package that brings everything together under one roof. SQL Server Big Data Clusters start with SQL Server running on Linux inside of Docker containers. Other containers running Apache Spark, Hadoop Distributed File System, and other components are mixed and matched and bundled together into pods. Then, groups of these pods are deployed into nodes on either physical or virtual computers. Finally, groups of these nodes are connected together to form the big data cluster. All of this is orchestrated by an open-source platform for managing containers called Kubernetes. In SQL Server Big Data Clusters, Kubernetes is responsible for managing the cluster by building and configuring cluster nodes, arranging nodes into three logical planes, the control plane, the compute plane, and the data plane, assigning and configuring pods on those nodes, and monitoring the health of the cluster. Each of the logical planes of nodes in the cluster is configured for a specific task. The control plane contains the Kubernetes master node, which in turn contains the SQL Server master instance. The control plane also contains other nodes for cluster-level services, such as the node containing the administration portal web server that administrators will log into to view dashboards and reports about the big data cluster's performance. The compute plane provides computational resources to the cluster. In it are nodes running groups of SQL Server on Linux pods. These pods are divided into compute pools for specific processing tasks, including acting as poly-based scale-out groups for accessing remote data stores. And finally, we have the data plane. Nodes in the big data cluster's data plane are used for data persistence and caching. Storage pool nodes contain pods that are made up of SQL Server on Linux, Spark, and HDFS containers. All of the nodes in the storage pool are part of an HDFS cluster, and these nodes are responsible for data ingestion through Spark and data accessed and stored in the Hadoop Distributed File System. The other nodes in the data plane make up a SQL data pool. Data pool nodes contain pods just running SQL Server containers, and they're responsible for storing the relational data of the big data cluster. All of the data pool nodes work together as a scale-out data mart, which means that the data is distributed across all of the nodes, allowing for parallel query processing against the curated data. In a SQL Server Big Data Cluster, Kubernetes will evaluate workloads and scale resources up by adding and configuring nodes in either the data or the compute planes when they're needed, and scaling back down by removing them again when they're not. So that's what big data clusters are. They're a group of several machines managed by Kubernetes that hook together a number of technologies for storing and querying big data and relational data stores. This is all accomplished in a single package that's supported by Microsoft. And really, it's that last bit that's the key feature, supported by Microsoft. Because really, there was nothing preventing people from rolling all of these technologies together on their own in the past. It was just complicated to do so. But now, with big data clusters, there's official support and documented workflows and engineering resources that are provided by Microsoft that'll enable many more customers to leverage and hook together these complex technologies in ways that'll make them more accessible to a wider audience. And that is what's cool about big data clusters.